Look at the nearest window. What you're looking through right now used to be sand, heated hotter than lava, until it turned into a glowing, molten liquid. Here's the part almost everyone gets wrong though. Some of the oldest windows in Europe are noticeably thicker at the bottom than the top, and for decades that was treated as proof glass never really stops moving. A liquid flowing so slowly it would take centuries to notice. That explanation is completely wrong. Glass isn't flowing anywhere. Physicists have measured this directly, and at room temperature, glass wouldn't visibly flow even if you waited longer than the current age of the universe. Those old windows are uneven because medieval glassmakers couldn't produce perfectly flat sheets, and installers often placed the thicker edge at the bottom simply for stability. But that myth accidentally raises a genuinely interesting question. If glass isn't a liquid, what actually is it? And how do you turn ordinary beach sand into something transparent enough to see through, strong enough to survive a car crash, and precise enough to become a smartphone screen? It starts with a surprisingly short ingredient list. Roughly 3/4 of all glass made today is soda lime glass, made from just 3 raw materials: silica sand, the source of glass's transparency; soda ash, which lowers the melting temperature; and limestone, added for durability and water resistance. Individually, none of these materials look anything like glass. Combined and heated to around 1700 degrees Celsius, hot enough to melt steel, they turn into a glowing, syrupy liquid. And here's the detail that explains the window myth perfectly. When that liquid cools, its atoms don't have time to arrange into the neat repeating crystal structure you'd find in ice or table salt. Instead, they freeze in place, disordered. Technically, glass is an amorphous solid, genuinely solid, just organized more chaotically than most other solids. For most of history, turning that molten liquid into a flat, usable sheet was brutally difficult. Glassmakers had to blow, spin, or roll it by hand, and the results were never perfectly flat or perfectly clear. That changed in 1952, when a British engineer named Alistair Pilkington had an idea that sounds almost too simple to work. Instead of fighting gravity, why not use it? His invention, called the float glass process, pours molten glass directly onto a bed of molten tin, and because tin is denser, the glass simply floats on top perfectly, naturally leveling itself into a flawlessly flat sheet under its own weight, with zero polishing required. The glass is slowly cooled as it glides across the liquid tin, then cut into massive sheets. It sounds almost too easy, but it was revolutionary enough that it's still, to this day, how the vast majority of flat glass on Earth gets made, from windows to mirrors to storefronts. Flat and clear is only step one though, or ordinary glass is also fragile and shatters into dangerous, razor-sharp shards. So, how does a smartphone screen survive being dropped, or a car windshield survive a crash without turning into knives? The answer is a process called tempering. Flat glass is reheated to nearly its melting point, then blasted with jets of cold air almost instantly. That rapid cooling causes the outer surface to contract and harden while the inside is still cooling more slowly, locking the entire sheet into a permanent state of internal tension. Compressed on the outside, stretched on the inside. That built-in stress makes tempered glass 4 to 5 times stronger than ordinary glass. And when it finally does break, that same stored tension causes it to explode into small, rounded, relatively harmless pebbles instead of long, dangerous shards. Which is exactly why car side windows crumble into gravel instead of slicing anyone. Here's one final detail most people never think about. Glass is one of the only materials on Earth that can be recycled infinitely without ever losing quality. Recycled glass, called cullet, melts at a lower temperature than raw materials, so every recycled bottle saves real energy compared to starting from scratch. So the next time you look through a window, remember, you're not looking through a slow-moving liquid frozen mid-drip. You're looking through billions of atoms that got frozen in chaos on purpose, floated flat on a bed of molten metal, and possibly strengthened by intentionally trapping stress inside a material engineers turned into one of the most useful substances on the planet. If this changed how you look at something you see through every single day, hit that like button and subscribe if you're not already, so you don't miss the next one. Let me know in the comments.